What's up, YouTube? It's Jordan, bruh, aka Cheat Buddy, and today in this video, I'm gonna be showing you some techniques for advanced, some advanced signature scanning techniques, I should put it, and I should be dropping a few more videos later today as well, even though it's like 11 o'clock, but I don't have work until like 3 tomorrow, so I got time to drop some content. But yeah, man, we gonna get into it. So you guys already know. You guys already know what we do. Go ahead and open your Cheat Engine client and select the game. All right. Now, shout out to the guy that requested that I do this video. Um, he hit me up on Discord and I told him I'd make something like it next. But this is basically for finding. Excuse me. This is basically for finding. Yeah. Excuse me. Finding addresses and basically finding just addresses and making signatures for them so that you can auto update your exploit and stuff like that. And so the addresses that he specifically wanted to find was the functions, the addresses for the functions in the Lua source code, which specifically is lapi.c, and this is where most functions for Lua are stored that you'd be using in your C code. Um, so yeah, and we're just gonna be going over a quick overview of how to find some of these just using Cheat Engine alone, um, and not using anything else. So right off the top, I would say when I was going through this um, source file, I noticed that like a vast majority of these functions we're calling a common function in Lua, which is index to a address or ADR. It's short for address, I believe. But anyways, this function is basically, Lua uses its own stack, and in order for Lua to see what's on the stack, or in order for the virtual machine to be able to retrieve data on the stack, it needs to call this index to a dir function, and that basically just tells it where in the stack that data is that what you're trying to access it. Just kind of think of it like as an array, and this function here returns a certain uh, pointer to that array. I think that's an easy way to look at it. But anyways, so this function is very common. You see it here in Lua insert. You see it here in Lua remove. Let's see where else if you could. We see it here in Lua replace. It's very common. If we were to do a Control F search for index to ADR, we get about 41 results on the page. So that just kind of tells you that a vast majority of these functions call this function. And I'm going to be showing you a little trick that you can use. So you could basically um, find all the addresses that call this function, and that will basically give you a better overview of what you're looking for. Um, so to do that, we're going to start off and go ahead and hit tools. And before we even try to find the addresses, let's go ahead and import the original Lua DLL. Um, if you don't have the original DLL, I could put a link in the description for you. But or you could just download Lua and get it that way. Do you want to execute a function for DLL? Go ahead and hit no. And the DLL has been injected. Okay, our game is still running, no problems. Alright, so right click, and you want to click go to address. And you want to type um, in my case, I'm just going to type in Lua get field. Okay, and so this is showing the Lua get field function. The code is completely in assembly or um, yeah, assembly language. This is just machine code, and I'll be doing a tutorial on how to understand most of this later on. But for right now, all we need to focus on is this call instruction. So call basically means what you think it would mean. It's basically calling a function. So in my case, I chose to look at Lua get field, right? So let me go to Lua get field. Okay. So in Lua get field, I see it looks as if it was calling a function here. It says Lua lock, but I believe that's just something for you to manually put into your code to handle thread locking, or not thread locking, but synchronizing your application with Lua, so that you're not, using the same thread or using the same Lua state on two different Windows threads, because that could cause your um, program to lock up and crash and stuff like that. So I believe that it's just a placeholder for that. So yeah, that wasn't an actual call, but then we see the second call here, and it says index to address. So we go ahead and open the sheet engine, and we see the first call here is index to, or not index to address, but we see the first call, just like here, the first call is index to address. That must mean that this call here is the index to address function. Okay. And if you were to go to the index to address function, you see it's doing a bunch of if statements check. This is basically what this C code here looks like in assembly language. And you could, let's say I click on Lua registry index. So Lua registry index is -1000, right? And if we look here, we see -1000. Let's go back. Where is it? Okay. So we see here if IDX is greater than Lua registry index. Okay. What this instruction is saying here, compare EAX. You could imagine EAX is that IDX variable. It's comparing it, and it's trying to see if it's this line here is comparing it. This next line here is saying um, if that IDX variable, or EAX in this case, if it's less than this value, this -1000, or if it's equal to that value, then go ahead and jump to this statement right here and run the code there. But we're not going to talk about that right now, because that's not what this video is for. I just wanted you guys to see here that um, these are the values that it's checking. So this is the basically the machine code equivalent of this C function right here. Okay. And so what we're going to do real quick, I'm going to pause the video because to get to the next step, um, I need to be able to show you guys a quick little technique that you could use to find basically all of those functions that are calling this index to address function. So to do that, you want to go ahead and hit tools and go to this set code and just hit on start, and just let that go ahead and scan, just let it complete. And I'm going to go ahead and pause my video because it might take a while. So I'm going to continue the video when it's done. Alright YouTube, so I'm back. That scan finished, and we're going to continue from where we left off. Alright, so as I said, we're in the get field function, and we figured out that this first call here was index to address. So just to make things a little bit easier, I'm going to go ahead and use the symbols, use the user defined symbols dialog to go ahead and just rename this to index to address so that we could better identify it. Oops. Okay. All right, so this is the index to address function. So let's go back to Lua get field. And so when you look at it, see it says index to address. All right. So since we know right now, obviously we're looking at the Lua, we're looking in the DLL of Lua. We're not looking at the actual Roblox process right now. We're in the Lua module. Um, and if you could see right now in this, for this specific address, you could see that the module for it is Roblox player beta.exe. In this case, if I were to enter the get field address right here, and it said Lua 5.1.dll. See, okay. So now what you need to do, this was something I was doing earlier. We'll get back to that in a little bit. Um, so what you need to do now, you need to find that index to address function, the Roblox equivalent, so that we can use it to find a bunch of other functions. And now this is just one method, and this is really This would be like your last case scenario, like the worst case scenario. If none of the other methods that I'm about to teach you work, then you'd use this method. I just wanted to get it out of the way because the other methods are more exciting. But anyways, what you want to do, you want to try to find this index to address function. And the way that we're going to be using this is by looking for scanning the bytes of the instruction, of the function, I should say, just scanning each bytes of the function. And in Cheat Engine, there are these things called wildcards that you could use. It's basically you replace, you use symbols as placeholders for bytes that should be there. So let's say if I was doing a scan and I wanted to find everything that said this test EAX, comma EAX instruction, it might say, instead of test EAX, comma EAX, it might say test EAX, comma EBX. And so you see that CO changed to a D8. And so in the case that I wanted to find both test EAX, comma EBX, as well as test EAX, comma EAX, I'd use what's called a wildcard. So you see the first byte here, the 85, that's the instruction or the opcode. So I put that 85 there. And then in place of that C0, which is for that EAX, I just go ahead and put a placeholder using two question marks. So that basically is a placeholder for that, so that the scanner will skip over it. It wouldn't look for anything specific. It will just search for that first byte, and then it will just skip that second byte and go on to the next one. So because I'm not sure what the game client is using, because theirs could say test EDX, comma EDX, test ECX, etc., and so on and so forth. And to get rid of that, to get not limit ourselves to just that one instruction, we use the placeholder or wildcards in that place. Okay, so next thing that you need to do is go on to the next line, which is here, the 7E. That's going to be the jump instruction. And you could kind of think of the first byte, so you could think of, and it's not always the case, but the first byte in that row is always going to be the byte for the instruction. And the second byte is normally the arguments, and the arguments is essentially basically the tell the instruction specifically what to do. So this 15 is telling this jump to go all the way down here, and yeah, that's basically what that means. So again, for arguments, you want to normally use um, the wildcards for. So I put that 7E, and then I'm gonna put two question marks to use as a wildcard. And again, the reason why we're doing that is, so we see it here in the DLL that it says 15, but it might not, in the actual Roblox client, it might not be jumping to this location. It might be jumping way down here. And so if it's going to be jumping further, then this wouldn't be 15, it would be something else. So that's why we use a placeholder right there. So next thing you want to do is go ahead and type in 8B, because again, that's the first instruction, and you want to hit first scan. Okay, so we still got a pretty decent amount of results. I'm going to go ahead and use the wildcards to skip the arguments. We hit next scan again. Okay, and we still have a lot of results. And you're going to head and hit C1. And so I noticed we have 12 results, but after inspecting earlier, and looking at each one of these, I know any instructions that's, above basically one, um, any instructions that's this large, basically, that's you don't see any zeros before them. Those are normally system DLLs. You don't want to normally mess with those. Everything else is fair game, um, meaning that you could modify those without any problem. If I disassemble each of these. Okay, so I see a few of them are in the Roblox client. We're just going to keep looking, and we're just going to see what we find. And essentially what we're looking for is a function that looks similar to the index to address function that we were looking at earlier. So we want to go to a function that looks similar to this function here. And to do that, we're just going down the list and just disassembling and seeing if anything looks like it. And so far, I don't see anything that looks like it. Now we're gonna keep going down the list and to the next one. Still nothing. And this one here is the Lua DLL. So yeah, that be careful whenever you're doing this because you don't want to find the. You might end up doing the scan because the scan is going to show both the Roblox and Lua, um, depending on how you do it. So in this case, I went ahead and scanned this C1 instruction. Okay. Now, from experience, I know that in some cases, the game might execute other instructions before others because um, in this case, the client uses a different version, or not a different version of Lua, but a modified version of Lua. So it uses its own version, meaning it might use the same instructions, but not in the same order necessarily. So what I've found is um, we see that there's this instruction here. It says multiply by 2 4 times. This basically stands for shift left. Um, so this instruction, we see it here, but whenever we do a scan for it, it doesn't show up within the Roblox module. So to get it to show up in that module, the first thing that we're going to do, I would say is do this. I'm going to go ahead and change start to Roblox player. Can't do that, huh? Okay, give me a second. I used to have a script for this. Okay. Basically, essentially, what I'm doing is I'm gonna um, set the range so that we are only scanning within the module and we're not looking for anything outside of it so that we won't be finding any, mixed up addresses. Like we won't be finding the Lua um, version of index to address because we are going to set our scan range to be limited to Roblox player beta.exe instead of Lua 5.1.dll. Okay, so to do that, you simply just press Control G or right click and click go to address. I always use Control G, so I forget to kind of mention it. But now you want to type in Roblox player beta.exe because that's the module name. You want to go ahead and click right click, go to address, and cut or copy that address. Okay. Um, you want to go ahead and put that in your start, and then um, just simple Lua script here. Excuse me. You're going to use that to find the end address, and I'm just gonna have it print out on the screen so I could use it. Oh, I don't print F is not a Lua thing. That's right. I'm so used to using C++, man. Um, believe it, this is how you do it in Lua. Oh, need to replace studio with player. That's the module name. Alright, there we go. So now we got the end address. And we could just go ahead and copy that and put it right here. There we go. So, we already went to that and we already inspect each of those and found that they're not what we're looking for. So go ahead and close this little engine, and now you're gonna go to Lua. Gonna go back to the index to address function. Okay. Matter of fact, you want to do it in this window because this main window, your main memory view window, which if I hadn't shown you guys how to open multiple memory view windows, all you do is just go to File and New Window. Okay. So anyways, I couldn't find this function when I put this C1 here, but that just might mean that there's other instructions for it. Like it might say this Leah first, and then it compare, and then it says the shift left instruction. Okay, so in that case, what I'm gonna keep doing is I'm just gonna keep adding wildcards, and then I'm gonna scan C1, and then I'm gonna keep checking those results to see what looks similar, and we're just going to keep going until we find one that looks similar to this index to address function. Okay, so disassemble. Um, I'm going to save this for later because that's going to be the next thing that we talk about. Let's see. Again, still none of this. This none of this looks like the function that we're looking at, the index to address. Okay, so add some more wildcards in them. C1 next scan. Still nothing. Do a new scan. Add some more wildcards. C1. Okay, getting a little result now. All right, and so look, this first one that we click on, as you can see, it has a bunch of stuff calling it, just like we had checked in the source file when we typed in index to address. Like I said, we found 41 results. And likewise, after you do that tools, the set code, it shows you that these are all the other places where this index to address function is being called. So, and so that kind of verifies that that's the index to address function. The other way to verify it is by going to the second mem browser, and here it is. Here's the version in the Lua DLL, and as you can see, just looking at them, they're very identical. So that's how you find functions. That's one way you could find functions with signature scanning. And essentially, after I tell you these last two methods, then we're going to go back to talking about this one, but you'd only use this as a last resort after you use the next two methods to figure out and just kind of eliminate, your list, because you're just going to basically be reverse engineering. You're going to be identifying each of these functions individually, figuring out what they do, and then that's going to kind of narrow down your list so that you have less less things that you don't know about, and um, you could just kind of check the other results rather than having to look at a big blob of different instructions. So the next way to find um, Lua functions is the infamous reference strings window. Now this basically stores a lot, and I mean a lot of actually, before we get to that one, I'm not going to talk about the strings right now. Before we get to that one, you remember if you haven't seen my Google hacking video, I recommend you go back to it. So the first method, whenever I'm trying to figure out um, what a to figure out a trying to find a function, I typically let's go back. I typically use Google, and I do a query search, a special query search to kind of narrow down the results. So this is something that I did earlier, okay? I wanted to find, I wanted to search the Lua source code to see every place where Lua get field was being called. So in order to do that, this was the search query that I looked up. So what I was saying here, I set the site to lua.org/source. This is so that it will should only show me pages on this website here based on this URL here. Okay, and then I put in quotes Lua get field, meaning the page has to have this field, which is why you see it in, or has to have this text that I put in here, which is why you see it in bold. Okay, and then I did the -lapi.c to get rid of that from my result, because this is just there's not going to be a call for a Lua get field in here, because this is just basically essentially setting all the C functions up. There's no calls to other functions. I mean, there are calls, but essentially, um, you know, I didn't. And in this case, I didn't want to use the source file. Now you were free to get rid of this last part, because um, you don't necessarily have to do it. It was just like a personal thing that I did. But anyways, when I did that, I saw this source file here, and I went ahead and clicked on it, and I just kind of did a Control F, and I did Lua get field, and um, I just kind of look around and see what function was calling it, what functions are calling it basically. And so the point of this is whenever you find um, other function calls, so let's say here, this function here says Lua open lib, right? If I were to find this Lua open lib function, that means in there I'm going to be able to find Lua find table, I'm going to be able to find Lua get field, Lua is table, Lua pop, etc. So on and so forth. Okay, so right off the bat, I noticed that there's a string here that says loaded. Okay, now that's something that you could possibly use to search, use reference strings and search for. The other one that I see here is name conflict for module. Okay, this is why I say it's very important to watch that video that I made on Google search tips and tricks, so that you could essentially, make it really easy for you to narrow down your search results whenever you're trying to find data. So go ahead and open up that reference strings menu, and you want to go ahead and hit Control F, right click, and press space here, or not space, but paste, and name conflict for module. Okay, now you see it here. It says name conflict for module, percent %s. That's not what we're looking for, so we're going to keep searching. But this one just says name conflict for module. Um, mm, mm, mm. Okay, so there's not any other results for name conflict for modules, and plus I see loaded here as well. So that's two good signs. I'm gonna go ahead and assume that Roblox probably just changed their version on the client to include that symbol, and we're just gonna click on it and see what we can find. Okay, so we go up to, let's go up, let's look at the function for a little bit. So I see negative 10002 so far, right? Now let's look at Lua registry index again. Lower register index says negative 1000. Okay, so far nothing. We're just going to keep going up. We keep going up. We keep going up, man. And here it is. We see it here. Negative 1000, right? Okay. What's right above it? Loaded. Loaded. You see? We see the string for loaded. Look. Look on the client. It says loaded. Okay. Now, when you understand assembly, you could kind of put things together and say, you could kind of figure out what this is. The push instruction, what that essentially does is it pushes information on the stack. What the stack is, you could kind of think of the stack as just storage for your program when it's running functions and stuff like that. It's just how it stores. It's just where it stores data and stuff to complete functions. It has all your local variables. In some cases it has your structures. All that information is stored on your stack, and so it also stores the arguments for function calls. So in this case, what these four instructions are doing, it's pushing, it's saying it's pushing one on the stack, then it's pushing this, this constant here, this constant which has the string loaded, then it's pushing Lua registry index, and it's finally pushing ESI, which ESI is the Lua state. Okay. And so you could see that that's four pushes, meaning four arguments, one, two, three, four, for this find table function here, okay? And you could already see, it's in backwards. So you see the one here, you see loaded here, and you see Lua register index, you see it here, you see L, that means that ESI has the Lua state, or ESI is L, okay? And now you see the call instruction. So once this is basically saying it's gonna put all these arguments on the stack so that it could call this function right here. And this essentially tells you that this function here is the find table function. So we could go ahead and click follow on that, and we could copy the address, go to view, user defined symbols, and you could just go ahead and type Lua find table and go ahead and paste the address here. And there you go. It's renamed to Lua find table. So if I go back, it's called Lua find table. Okay. And as we can see under Lua find table, after Lua find table is called, then it says here that get field is called,
All right, sorry about that, YouTube. I had to stop the video real quick because I needed to show you guys a quick, just a quick reference to make you understand things. So it says here that after find table is called, then get field is called. How do I know that this is get field? Well, right off the bat, like we said, ESI we knew ESI is Lua state or the L here, and then we see the negative one, and we see lib name is being passed to it. Um, Now, what is libname? It says here that libname is a argument. It's a const char. In other words, it's another form of a string. It's just a string being passed. So when this open lib function is going to be called, you're going to pass a string to it in this field here, and that's what libname is. And then get field is going to be called with libname. Now, remember how I was telling you about the stack, how the stack stores how the stack stores arguments or parameters, or yeah, basically arguments for the functions to pass to the function parameters. Okay, so what I have pulled up here real quick is the Intel calling convention, and you could kind of see the variables. In this case, it's going from negative to positive. It's going from minus to up, and so in this case, we see that up here these are parameters. And down here, the negatives are variables. So in assembly, on EBP, that's your base pointer for the stack. It basically holds it's normally the stack frame typically, and that just holds all the values from the stack. Okay, and you could use EBP to access go if you go down, you're accessing local variables. If you go up, you're accessing arguments and function parameters, which is all this stuff here within the function. Okay, so um, this function here is saying push EBP plus C. Now you might be wondering what that C is. The C is in hexadecimal. If you were to take the Windows calculator and go ahead and switch over to the good old programming calculator, you want to go ahead and click on hex and then press C, and you can see that C is the equivalent of 12. So what this is basically saying is EBP plus 12, okay? Because everything in machine code is represented in hexadecimal. So you might not be able to understand it right off the bat until you learn hexadecimal. But anyways, we could see here for 12. Like I said, going up, we know it's a plus. So plus 12, this means the second function parameter, okay? And when we go back to the function here, we see libname, that's the second. This is the Lua state is the first, the libname is the second, and so on and so forth. Okay, so when it's calling get field here, it's calling libname. Like I said, libname is that plus 12. So that's what it is. And there's that negative one, and there's the state. So now we know that this right here is get field. And we could go ahead and copy the address. And we could go ahead and do Lua get field. And then in the address, just paste it here and then click add symbol. And now it's going to say Lua get field right there. Okay. And you go back. And there it is, little get fill. So you could keep doing that for all the functions down here and so on and so forth. And then, um, so going, oh crap, I did not mean to do that. Shit, dude. I did not mean to fucking do that. Okay, here we are. We're good. No biggie, no biggie. Okay, so, guys, the reference strings, using Google Hacking, you could basically find these different strings and you could search them to see if they're Lua related. So, going back to my little query here, or not that, this one here. Crap, here it is. Okay. So, let's say I was looking for something else. It says, um, which one would I try next? Mm, there's a lot to choose from. Okay, tell you, you know what we're gonna do? We're just gonna go through the Lua source file. We're gonna look for some strings, and then we're gonna try to find that string in the and try to find that string in in the reference strings. Okay, so here's an example of this Lua where. Now, if you want to define Lua push string, um, you could go ahead. You want to find in within this function, you got Lua push string, you got Lua get info, Lua get stack, Lua push literal. If you want to get all of that stuff, you just simply look up this thing here. You go to reference strings, Control F, right click paste, and then there you go. You see it here. And now we click on it and look at that. Boom. Right off the bat, you could tell right here that this is push F string. So we could just go to it. I use Control X to cut the address so it's faster for me to copy, by the way. So there we go. That's another one that we got. Yeah, so there it is. It says little push F string now. And you could keep repeating the process, guys. This is really simple. In the case that you're not able to find something by a string, then that's when you would do that first method, which is the signature scanning. You'd go to a function. Let's say you wanted to find like Lua new thread. You go to Lua new thread, and then you copy those bytes. Just to review, you copy these bytes, and for the arguments, you want to use wildcards in place, and you see what you can find. And, you know, if that step doesn't work, then I recommend you go ahead and use the strings, the reference strings method, and just using the Google hacking method that I taught you guys to find different strings and stuff. And then as a last resort, you could, if none of those are working for you, you could go to that index to address function, and then well, this is the Lua variant. I don't know if I saved. Let me see if I saved the other one. Um, I might have it. I don't think I have it saved, but I might have it end of. It might be here in the find table function, or one of these functions. I might have it. Yeah, here it is. Here it is. So yeah, if you can't use if none of those other methods work for you, then as a last resort, you could use this method here, and that method just basically involves going through each of these, individually. You'd already know some, so you could knock them out of the way because using the first two methods, you'd already knock some of these out, so you'll already know what they're for. And then you could just look at the rest for whatever specific thing you're looking for. So, yeah, guys, that's it. Hope you enjoyed the video. Make sure to like, subscribe, share the video with your friends, or um, you know, just try to get the word out about my channel because I'm really trying to make some unique content and really get a good, decent, growing community going that are pretty knowledgeable in programming and reverse engineering in general. So yeah, if you could do that to me, for me, I'd appreciate it, guys. Thanks, and appreciate everybody that's been subscribing and keep letting me know what videos you want to see next so I could make them for you.